Your signal generator has two leads. It'll have a positive lead and it'll have a ground lead. And most alignment procedures require you to stick a capacitor, or they tell you to stick a capacitor on the positive lead of the signal generator, and they call it a dummy load. The purpose of the dummy load is to keep DC voltages from the radio coming back down the line and going into your signal generator and frying something, burning something up, destroying something. And usually it's a 0.05, maybe a 0.1 microfarad capacitor. So when that happens, this is how you hook it up. You just connect it on, and then the other side you connect a little gator wire, and then hook your gator wire into your radio wherever it needs to go. I don't have to do that with this set of leads that I purchased for the triplet signal generator, because that dummy load is built into the line right there. It's got a little lump. I don't know if you can see that lumper right now. See that lumper now? There it is right there. Always present, so I don't have to worry about a dummy load. Cool, huh? The next thing I need to mention is when you use your signal generator and you're adjusting your intermediate frequency, which would be your IF cans, first and second. The level of the signal that you use should be just barely enough to detect by ear and by the meter that the output meter that you're using for the alignment procedure. And that's controlled once you set your frequency to what you want and you verify it on your frequency counter. You would go ahead and set it to the lowest. Start out with high, and then crank down your attenuator, or your volume is really what it's called on my Heath kit up here. It's called coarse attenuator. Got a switch at the bottom, and then they have what they call fine attenuator. You know, big deal, huh? No difference than these here RF selectors, what they call this one, and they call this one attenuator. Same knobs as what's up there. So you always want to have your signal as low, just barely what you need in order to adjust your IF cans. All the equipment is warmed up for about half an hour, maybe a little bit longer. And before I start, I wanted to show Matt, one of my viewers, this wooden bristle, brass bristle brush that I use. Some of you have seen it in my other videos. I use it to clean the tube pins. All you got to do is just take them and scrub those tube pins. Scrub, scrub, scrub. And it does not remove the plating off the pin. It does a very good job. Some people use, spray contact cleaner, but this shines them up, makes them look real good, gets all the crud off, all the way down to the glass where the pins go in. So there you are, in the paint department, Walmart, very cheap, $1 or $2, maybe $2.50, I don't know. Come one to a package. They used to come two, but I think they're just one now. So there it is. Alright, that's done with. Time for the alignment procedure. Every schematic has usually in large letters the intermediate frequency written right on it. In this case, the intermediate frequency of this radio is 460 kilocycles. IF equals 460 kilocycles. To do the alignment on the radio, I need to remove the grid cap from the 6A7 detector oscillator. And then I need to connect the signal generator positive lead to the grid cap. So let's do that. The small alligator clip on this signal generator lead is too tiny to get across that, to clip onto that grid cap. I've removed the wires, you can see here. Let me get it out of here where you can take a look at it. I removed that grid cap wire, just plucked it off of there, moved it out of the way. Stick it down here somewhere where it won't touch anything. And then what I'm going to have to do is a little adaptation here. I'm going to take a larger clip onto the grid cap there, make sure that nothing hits the tube shield. That's why I'm keeping the insulator on. And then we'll take the red lead and clip it to that clip. And already you're beginning to hear something. and then the ground comes over and gets clipped to the ground connection over here. See, already we're hearing a tone. Hear it? Alright, now what we're going to do, like I said, is now that we've got the IF set up, the first thing we're going to do is adjust the two IF cans, which is this one and this one. Then we'll go ahead and adjust these three others. Now, how do I know all this stuff? How do I know these things? That I'm supposed to remove the grid cap, hook up the signal generator to it, and then I'm supposed to adjust the second IF, first and secondary, and then the first IF, first and secondary. How do I know all these things? Well, it's pretty easy, really. It's in the radio's alignment procedure. It doesn't take a whole lot of brains to follow one. This radio starts its alignment procedure out right there on the bottom. It says adjusting compensating condensers. It tells you how to set up your signal generator. It tells you how to adjust your IF, which if you'll look there, it says adjustment of IF. Second paragraph down here at the bottom. And then I will move on to the rear of the service bulletin, and it tells me how to adjust the wave trap up there in the top left center. And then over here in the right paragraph section, it tells me how to adjust the 3 sets of coils in these 3 cans. Step by step, piece of cake. So it told me to set up my signal generator for 460 kilocycles, which I have done. It then told me to remove the grid cap from the 6A7 tube, which I have done, and to connect the red lead or the antenna lead to that grid cap, which I have done. Now what we have to do is, let me see, what we have to do is adjust the signal generator, which we have done, and adjust the attenuator for approximately a half scale reading of the output meter. By now, some of you have probably noticed that Part 30 and Part 31 of this series has been taken down after it had been uploaded, which involved the 2-part alignment of this radio. There's a reason that happened, that those 2 videos disappeared. The alignment procedure was done correctly. Everything, the signal generator was connected properly, the frequency counter, and the wiring to the speaker, and the vacuum tube voltmeter, and the actual alignment procedure of the radio was all done the way it's supposed to be done. Unfortunately, if you'll recall, we had really bad meter movement on my vacuum tube voltmeter. I couldn't get the needle to do what it was supposed to do. Well, I was contacted by a guy, one of our viewers. I think his name is, his YouTube handle is Eckerman or Eicherman, I'm not sure which. And he said, John, in a very tactful way, he said, John, you know, you'll get, essentially he said, you'll get a whole lot better meter movement if you place the function switch in the AC position as opposed to the DC. He was 100% right. I couldn't believe I had DC on the brain that day. So, we now have the meter back in the AC position where it's supposed to go, and everything is warmed up for a half an hour. So what we're going to do is we're going to go ahead and go through the entire alignment procedure from scratch again. And you know, I figure what the heck, it won't hurt the guys who have never done it. It won't hurt for them to see it a second time. And make sure that your probe switch, whether it be a thumb switch here or this one, or a Heathkit style here with the switch on the end, make sure the probe switch is in the AC position as well. According to the alignment procedure, we're supposed to adjust our frequency counter to 460 kilocycles, which is the intermediate frequency of this radio. And then we're going to adjust the primary and secondary adjustments for the second IF, and then we're going to go over here and adjust the primary and secondary adjustments for the first IF. So that's the first 2 things we have to do. Once we get done with those 2, we'll then go to the rear of the chassis back here and adjust the wave trap. The IF can adjustments are done, there's a screw in the center there with a slot, and there's a nut around the outside. And the same thing on the first IF can. A screw in the center and a nut on the outside. The screw is the primary adjustment and the nut is the secondary. Alright, the first adjustment is the primary of the secondary IF, or the second IF. And we're going to just turn it a little bit left and right and watch the needle movement this time, as opposed to the last video I uploaded. Last one, they just barely moved, but when you go to AC, this is what happens. Let's turn it. Look at that. Is that amazing? Lesson learned, fellas. Pay attention to your function switch. Okay, we're going to bring it up, up, up. Now, all the way to the right. The highest point of this scale on all of these scales is to the right. So we're going to bring it up, up, up until she crests over. There, it crested over. See it? See it? Now we'll go back the other way. And it will crest over and go back down again. What we're looking for is that high point. Up, 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 right about there. Tweaky, tweaky. Alright. Now we're going to take this little wrench, this little spin tight. I've got some tape around the socket, which was recommended by All American 5 Radio, and so I went ahead and did that. Now we're going to put that around the socket, around that little nut right there, and we're going to adjust again. Now this one probably will be not quite as, it's going up, 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 and there she's cresting over. See there? Now we'll go back the other way, up, 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 tweaky, tweaky, tweaky. Alright, that takes care of the second IF. Now we're going to do the exact same thing to the first IF. The screwdriver is in the hole, and we're going to tweak, 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 tweak. Oops, she's going down. Wrong direction. Up, 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 up. There it is. It crested back over and going down. Back the other way until she reaches that high point right there. Now we take the spin tight and put it on top of the secondary of the first IF. We're going to adjust it. Back the other way. Back, 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 back. Until she peeks out. More, a little bit more, a little bit more. Oh, there it is. It's cresting over. We don't want that to happen. So we'll go back this way. There it is right there, the crest over point. Okay? That's it. That's as high as she's going to go. And that's how you adjust the second and first IF coils in this particular radio. One other thing I wanted to cover. Once you hook up your vacuum tube voltmeter to either the socket terminals under the radio, or follow the wires on out and connect them to the speaker, the primary of the audio output transformer. Once you do that, do not touch that thing. Stay away from it. Do not unplug the wires and plug them back in with power applied to the radio. A lot of voltage there. A lot of voltage. You will get stung bad, okay? And I know this from experience. Now it says under the wave trap, in order to adjust the wave trap, you have to take the grid cap connector, put it back on the 6A7 tube, and then connect the signal generator positive lead to the antenna connection, and then leave the negative lead to the ground connection. And then we will take the spin tight, put it in this hole back here. And I showed you on a previous video where the adjustment was for the wave trap. We're going to go ahead and adjust this wave trap for a low point on the scale, whereas for the IF cans we wanted a high point. Now we're going to adjust it for a low point by injecting that 460 kilocycle signal into the radio. So let's get this all set up. In addition to commenting on the function switch on my vacuum tube voltmeter, Brother Eicherman said, you know, to adjust that wave trap, your signal generator may not be enough of a load to do it properly, and he suggested putting a 1K to 100K resistor in line with the antenna connection that goes from the signal generator to the antenna connector back here. So I said, hey, that sounds like a good idea. Well, let's give that a try. So I stuck a, he said 1 to 100K, so I stuck a 51K ohm resistor in line with this wire coming from the signal generator. So let's see what happens now. Let's go ahead and I'm going to bring up the signal. I'm going to bring up the volume rather on the radio. It's up all the way. And we'll just bring down the attenuator on the signal generator till it's about right in here somewhere. Now, with that 50K ohm resistor in there, 51K, let's see what happens on the meter. We're looking for a low point. A low point. It's very touchy. There's something very touchy here on this thing. Let's try it. Okay, here we go. Let's go down 1 scale and 2 scales. Alright, we're going to adjust this thing, see if we can get it to go low. We want the needle to go low, which was just the opposite of what we did on the IF cans. Let's see what's happening here. Which direction do I want to go? That's the wrong direction, that's for sure. We're going to go down. Down. Oh, she's going down nicely. Down. Oh, she's touchy though. Touchy, touchy, touchy. Down, 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 down. Down, down, down. Way down. As far as she'll go. That's about it. Back the other way. There it is. Boy, she's touchy, touchy, touchy. There. I think that'll just about do it, because we're on the 1 volt scale, so we're way down there. Well, that's it. Brother Ackerman's idea of the putting a load resistor on the wave trap before adjusting it works quite well. So a big shout out to him, not only for the knob function setting, but for this here too. Thank you very much. I appreciate that. Also, our brother Ackerman just subscribed to my videos. Why he would subscribe to my videos is beyond me. He obviously knows a lot more about this stuff than I do. He probably wants to see the dummy make another mistake, maybe. I don't know.